we introduce the binomial probability formula. In a binomial experiment, the probability of exactly x successes in n trials is denoted by p of x, which is n factorial divided by n minus x factorial times x factorial p to the x q to n minus x. Well, officially, we can say that if random variable x follows a binomial distribution, then the cumulative density function will be denoted by b of x and p, which is the probability that x is less than equals to x, which is the summation of all of those probabilities less than or equals to x. For example, a survey of US adults found that 62% of women believe that there is a link between playing violent video games and teens showing violent behavior. You randomly select 4 US women and ask them whether they believe that there is a link between playing violent video games and teens exhibiting violent behavior. Find the probability that exactly 2 of them respond yes, and find the probability at least 2 of them respond yes. So for finding the probability of exactly 2 of them respond yes, n is 4, the probability of success is 62%, which we can just see right here. Q, which is the probability of failure, 38%, x is 2. So the probability of having exactly 2 positive responses is about 33%. So you just punch everything into the formula. Since it says exactly, wherever we see x, we're going to use 2. And since n is 4, you get 4 factorial divided by 4 minus 2 factorial, 2 factorial, and the probability of success, which is 62% to power 2, and the probability of failure, which is 38% to power 4 minus 2 or 2. Now, to find the probability that at least 2 women will respond yes, we need to find the summation of P of 2, P of 3, P of 4. So you're basically adding all of these together. The probability of 2 is about 33.3%. Probability of 3 is 36.23%. The probability of 4 is about 14.78%. So if you add all of these together, the probability that you have at least 2 positive responses is 84.3%. You can also use your calculator, or if you're using any other software, it helps to do the calculation a little bit easier. So sometimes using a calculator or a software makes it much more easier to do the calculation. But I want to show you how to use the formula to find the probabilities as well. If x follows a binomial distribution, the expected value of x is n times p, and the variance is npq, and the standard deviation is square root of npq. So these are important information about the binomial distribution. For example, in Pittsburgh, Pennsylvania, about 56% of the days in a year are cloudy. Find the mean, variance, and standard deviation for the number of cloudy days during the month of June. Okay, first of all, we have a binomial distribution. There are 30 days in June, so n is 30. The probability of success is 56%, as you can see just right here. And Q is 1 minus 56%, so you get 44%. You can find the mean and variance and standard deviation below. Mean or expected value is n times p, which is 30 times 56%, which is 16.8. The variance is npq, which is 30 times 56% times 44%, which is about 7.4. And the standard deviation is the square root of npq, which is about 2.7. What's the meaning of that? It means that on average, there are 16.8 cloudy days during the month of June. The standard deviation is about 2.7 days. The values that are more than 2 standard deviations from the mean are considered unusual, because 16.8 minus 2 standard deviations is 11.4. A June with 11 cloudy days or less would be unusual. Similarly, because the mean plus 2 standard deviations is 22.2, a June with 23 cloudy days or more would also consider as unusual.